All right, let's take a look at number 3. Name. So we're naming. We're not doing formulas here. Name the following compounds using the stock system. Okay. There are some chemistry books that want you, when they ask for the stock system, to use the parentheses and the Roman numerals to identify the charge of the cation, no matter what. Okay, like there are some books, like for this first one, and I'll just tell you that the answer that I want is sodium iodide. There are some books and some teachers that when you're practicing, they really put an emphasis on this is the stock system, this is the prefix system. They really want you to categorically understand the systems, which is fine, but that's not the way I'm going to go about this. What I'm wanting you to see is that this is a main group metal. Sodium is a main group metal, and since it's a main group metal, it forms a very predictable charge, so you don't have to tell me what that charge is. Okay, does that make sense? So it's sodium iodide. And again, I'm seeing here main group metal, so it's a very predictable charge. It's going to be a +2, right? So I don't have to tell you what the charge of this magnesium is because we already can anticipate what it is. So we'll just go magnesium sulfide. And again, don't forget the IDEs here. Don't forget the IDEs when we talk about those monatomic anions. All right, so here we have calcium, another main group cation. I can predict its charge, so I just leave it calcium. No Roman numerals there. And then oxide. We have potassium sulfide. And again, some students struggle with this, so I'll say it again. The reason that we don't have to say this subscript 2 to communicate that there are 2 potassium atoms is because everything here forms a predictable charge. I can know that when you say potassium sulfide, the fact that you said sulfide tells me that that's a sulfur anion. Looking at the periodic table, I see that sulfide is always going to form a -2. Looking at the periodic table, I'm also going to see that potassium is always going to form a +1. So in order for those 2 charges to cancel each other out, I'm going to need 2 of the potassiums, right? So because I can predict the charges, I can also predict how many of each atom I need. I don't actually have to tell you what the charges are. But when we get to E and F here, now we're using transition metals. And transition metals form a variety of charges, okay? Some even form 3 different charges. So we have copper here. I'm going to start the exact same way. Copper, bromide, okay? But now I'm going to have to look at the anion. Okay, so I've identified that it's a transition metal, and so something is awry. I'm going to have to use the Roman numerals to tell you what the charge is. And look at Br. I see that bromine is in main group 7, so it's going to form a -1 charge. And I can see here from the formula that there's only 1 bromide. So how many overall negative charges are there? 1. So that means that the cation only has to offset 1. So this is going to be copper 1 bromide. So when I say copper 1 bromide, yeah, I'm saying, hey, this is the type of copper that has a +1 charge. So when I say bromide, like, oh, bromide I know has a -1 charge. Oh, this is just one of each. It's just one of each to balance out. All right, on to F. So I'll go iron. Okay, is the cation there? Don't know what the charge is yet. So I'm going to put something in parentheses here. And chloride. Again, it's very easy if you start by looking at the anion. Chloride. Chlorine is in main group 7, so it's going to form a -1 charge when it's chloride, -1. But I look at the formula and I see that there are 2 of them. That means that I have 2 overall negative charges. So since there's only one iron atom, it means that this one iron atom must be responsible for offsetting both of those negative charges, right? So that's going to be an iron 2 chloride. One last thing. You want to look for what in the question, what in the prompt, what in that formula, what in that name is cueing you to use that certain system, okay? And the difference between A, B, C, D, and then E and F, the difference between those two types of problems is that these are all main group metals. Sodium, magnesium, calcium, potassium, all main group metals. But when we got to E and F, transition metals. So when you see an ionic compound that has a main group metal, like, aha, balance the charges, no Roman numeral. When you see a transition metal, like, aha, it's an ionic compound, but I need to use the Roman numeral.